Welcome to Brain Vision.
In this question is about finding the force on a current loop in a non-uniform magnetic field. Okay, so we are given the magnetic field is E naught Z over L J hat plus E naught Y over L K hat. Okay, and then we are also given the current loop. So the current loop. Okay, so the current loop is on the XY plane, right? So it's a square loop. Okay, the side length is L, and then the current is going clockwise. Okay, so in part A, we want to draw the magnetic field on the Z plane, YZ plane. Okay, there are three parts in this question. Okay, so it's guided such that we can find the magnetic force on the whole loop. So in part A, we will first draw the magnetic field in the YZ plane. Okay, so this is how it's going to look like. Okay, so along the y equals to z line, okay, the B field will just be pointing along the diagonal. Okay, and then starting from each axis, okay, suppose on the z axis, the value of y is 0, so you will start off pointing to the right, and then you start going up. Okay, same thing over here, start going up. And then on the y-axis, that's where the z equals to 0, right? So initially, you start pointing along the k direction, and then you start curving along the y equals to z line. Okay, yeah. So that's how the magnetic field look like. All right, so along the in the YZ plane. Okay. Okay, now in part B, we want to find the force, the magnetic force on each side of the current loop. Okay, so part B, okay, let me draw the current loop again. Okay, right, so to find the magnetic force, you'll be using the formula F equals to IL cross B, IL cross B. Okay, since we have non-uniform magnetic field, so we will be doing integration. So this is the equation that we will be working with, I dl cross B. Okay, then we will do side 1, label each side as 1, 2, 3, 4. Okay, and we'll just work out the dl accordingly. Okay, so we are given that B is B naught C over L J hat plus B naught Y over L K hat. Okay, on the xy plane, Z equals to 0, so B is equal to B naught Y over L. Okay, k hat. Okay. Then for side 1, okay, our dl is along the j hat direction and dy. Okay, so we are going to have j hat cross k hat. Okay, this is going to give us I hat, and so our f is going to be integral of I dl cross b. Okay, so pull out the constants, ai b naught over L. Okay, and then the integral is from 0 to L y dy, and then the direction is I hat. Okay, so we have half I b naught L I hat. Okay, so this is F1, the answer for F1, and then we'll repeat for F2. Okay, for side 2, okay, our dl is dx I hat. Okay, so our dl cross b, the unit vector, right? So is I hat cross k hat is going to give minus j hat. Okay, so our F2 is integral of I dl cross b. Okay, you can pull out the constants, which should be b naught over L I. Okay, so the integration is along dx from 0 to L minus j hat. Okay, so this is oh, there's also one thing, the y is equal to L. Okay, forgot to mention y is equal to L, so there is actually no L term over here. Okay, b naught, then you get minus I b naught L j hat. Okay, so this is F2. Okay, the top side. Then for side 3, okay, we have dl is along the dy, okay, j hat, and then the dl cross b unit vector, okay, is j hat cross k hat. This is equal to I hat. Here we have x equal to L, but it's not going to affect the equation because there is no x terms inside the terms that we are given. Okay, so we get pull out the constants I b naught over L. Okay, and then we are going to integrate y dy. Okay, now it starts from L to 0. Okay, because it's going down. Okay, and then this is I hat, and then if you integrate, you get minus half I b naught L I hat. Okay, so this is F3. Now we do F4. Okay, F4 for side 4. Okay, now we have y equals to 0, so b is equal to 0. Okay, so f is equal to 0. Okay, f4 is equal to 0. Alright, so that's all for part B. Now we want to find the net force in part C. So F net will just be the sum of all the 4 forces that we found in part B. Okay, so you have half I b naught L I hat minus I b naught L j hat minus half I b naught L I hat plus 0. And you can see that these two terms cancel out. So we are left with minus I b naught L j hat. Okay, so this is the net force on the current loop. Okay, and that's all for this question.